In this video, we are going to learn about how to solve exponential function. So exponential function means a function of the form. So we have some base and then you have a function equal another function. So that is the kind of a function that we're going to solve in this one. So the goal is to solve this for x. So solve for x. And the assumption is we assume that a is positive and a not equal to 1. So when you have an exponential equation, there are three types. So there are three types. So the first one is what we call the same base. The equation has, in both sides, the equation has the same base. So the first one is the same base. And the second one is different bases. Different bases. So in this case, we assume that the equation has two terms. So this is a two-term equation. Two terms. And then the third type is what we can say is like more than two terms. So more than two terms. So those are the three different cases, and we're going to solve one by one with details. And also you can look at this in a different way. So the exponential equation can be break into two different types. The first one is two-term types or more than two terms. So if there are two terms, you can have it as the first one has the same base, the second one is a different basis. If you have different bases, you can bring that again into two types. So first one is can be brought to the same base. That's the first one. The second one is cannot bring it to the same base. And we can do problems from each type. And the next one is more than two terms. When you have more than two terms, we can do two things. First one is you're going to rewrite it as two terms. That's the first type. The second type is you're going to use a substitution. So we're going to substitution method. So those are the types that we're going to consider in this one. So let's talk about the major theory. So the theory is we know that the exponential function is one-to-one. Why it is one-to-one? And you can see that if you look at the graph of those two, for a greater than 1, you get an increasing function. For a between 0 and 1, you get a decreasing function. And earlier we learned that if a function is increasing or decreasing, it has to be one-to-one. So that is the reason why the exponential functions are one-to-one. And then we know that if a function is one-to-one, what happens? So if f is one-to-one, and we know this major theory. If a function is one-to-one, if the function values are the same, then the input values should be the same. So that is the argument that we can use here if a function is one-to-one. So that means for exponential functions, what happens for exponential functions, we have this one. So we can say that if the exponents, if ax equal ay, this should implies that x equal y. So we're going to equate the index. So that is the property we're going to use to solve exponential equation, especially when they have the same base. So let's look at some of the examples now. So as the first example, we can solve this one. So this is the type 1. So this is the type 1. So let's solve this problem. So we can solve 2 to the x equal 2 to the 3 minus 2x. And you will notice that the bases are the same. So since the bases are the same, since the exponential function is one-to-one, so we can say since the exponential function is one-to-one, what we can do, we can equate the exponents. So we can write x equal 3 minus 4x. But if the function is not one-to-one, you cannot do this. Okay, so we equate the exponents. So we pick the exponents and set them equal. So now what we can do, we're going to solve this one for x. So this is very easy. You can bring the negative 4x to the other side. So I mean you can add 4x to both sides. You can write this one as, after you doing that, you're going to say 5x equal 3, and then we can divide both sides by 5. So the x equal 3/5. So that is the solution. So the solution is x equal 3/5. Good. So let's look at the next one. So we have this one as a second problem. So 1/3 to the t squared power equal 1/3 to the t plus 2. So t is the variable. So it doesn't matter what the base is. So here the base is 1/3. So a equal 1/3. So again, what we're going to equating index. So click indices. So we have t squared equal t plus 2. Now we're going to bring it to one side. So we can write this one as t squared minus t minus 2 equals 0. So the next one, what we're going to do, we're going to factor. So if you factor, and you can see that this is easy to factor, we have negative 2. You can write this as negative 2 and 1. So that means t minus 2 and then t plus 1 equals 0. So we're gonna, so what we did here is we factor, and then we're gonna set them equal to 0. So we're gonna set condition equal to 0, or t plus 1 equal to 0. So if you're adding 2, so t equal 2, or t equal negative 1, and you can see both works. So the solution is, so you can say t equal 2, or t equal negative 1. Good. So that is, so these are the ones that have the same base. So let's try to do the second type. The type 2, we have different bases. So type 2, different bases. So under this one, we go to the first type again. So bring into same base. Bring into same base type of problems. So let's look at this problem. So we're going to say solve 3x, let's say 3 to the x squared, 3x squared equal 9x plus 4. So if you look at this problem, you can see that they have different bases. Even though they have different bases, there's an interesting relation here. We know that 9 equal 3 squared. So 3 squared is 9. So we can use that fact now. So that means we can rewrite 9 as 3 squared. So so we can say, since 9 equal 3 squared, we have 3x squared equal, I'm going to replace 9 by 3 squared. So we can say 3 squared x plus 4. Then we can use one of the algebraic property. So we know that if you have a to one power and another power, you have power of a power. When you have power of a power, what we can do, we can multiply the two powers. So this is simply equal to x times y. So we can use that result. So we're going to multiply two powers. So we can use the same result here. That means we can rewrite this one as 3. By multiplying the powers, you can say 2 times x plus 4. So that means, so we have now this equation, 3 to the x squared equal 3 to the 2x plus 8. Now since they have the same base, this is going to be the previous type. So we're going to simply equate the index. So those are the index, one in blue. That means, so we say equating index, equating indices. We have x squared equal 2x plus 8. So this is simple algebraic equation, and then we can solve this by factoring. So we're going to bring it to one side and factor. So the next step would be x squared minus 2x minus 8, and then we can factor this. So we have negative 8. We can write this as two numbers. When you multiply, you get negative 8. When you add, you get negative 2. That means the numbers are negative 4 and 2. So that means your factoring would be negative 4 and x plus 2. Equating each factor equal to 0. So negative x minus 4 equals 0, or x plus 2 equals 0. So this says that x equals 4 or x equals negative 2. So those are the two solutions. So let's look at the next one. So let's say solve 12 times 3 to the 1 minus x equal 4 times 27 to the 5x plus 7. So here there are several problems now. So you can see that there's a number you multiply with that doesn't have index. Index is 1. And also these two terms have different bases. So that means you try to figure out whether you can rewrite this using one base. So it looks like you can rewrite all of them using 3. The reason is we know that 27 is 3 to the cube. So because of that, we may rewrite this using only base 3. So the first thing we can do is we can divide both sides by 4. So the answer, we can divide by 4. Okay, so dividing by 4, dividing by 4, we can rewrite this one as, so it is 12 over 4 times 3 to the 1 minus x. That's the first thing. And the 27 you can replace by 3 to the cube. So it is 3 cube, that's 27, to the 5x plus 7. 12 over 4 means 3, so you can read this one as 3 times 3 to the 1 minus x equal, again as we did before, this is 3 to the 3 times 5x plus 7. Now 3 means 3 to the 1. So you can, at the index, you can rewrite this one as 3 to the 2 minus x on this side, because you can add the 2 index. So we're going to add 1 and 1 minus x. And then on the other side, you can multiply. So you can write this one as 15x plus 21. Now you can see that this is in one base. So after you get one base, this is a problem that we, like a similar problem that we solved earlier. So we're gonna equate the two index. So equating indexes, equating indices. So we can write this one as 2 minus x equal 5x plus 21. And then so what we can do is we can bring all the x's to one side, the numbers to the other side. So this is going to be, you can bring 21 to this side, so you're going to be negative 19 equal, if you bring x to the other side, you get 6x. That means x is simply negative 19 divided by 6. So that is the x equal negative 19 over 6. So that's how we solve the problem. So these are the ones you can bring it to the same base. So let's try to talk about problems that you cannot bring into the same base. So type 2 part B. So cannot bring it to same base. So if you cannot bring it to same base, what we can do, we're gonna follow like a like 3-step method for this one. So what we can do, normally for these problems, the first one is we're gonna isolate the exponential terms. So we can isolate the exponential terms. And then we can do one special thing. We're gonna take the log of both sides. So take what we normally call take ln. Ln means natural log of both sides. So that is the major step that we can use to solve problems that you cannot bring into the same base. So take ln of both sides. And then the third one is we're going to solve for the variable. So solve for the variable. So let's try to see. So this is the major step. We're going to take lnf natural log of both sides. I mean, it can be, it can even be some other bases, but we're going to say natural log. That's like most common one. So we're going to follow these three steps to solve a problem that you cannot bring into the same base. So let's look at the first problem. So solve. Let's say the first one, 2 to the x equal 5. And then you can see that the bases are different. In one side is 2, one side is 5, and you cannot bring one base to the other. I mean, you can generally bring any base to anyone, but the problem is because we had a result in when you talk about the exponential function, we remember we had a result like that, ax equal e to the x ln x. So using ln a, e to the x ln a. So using this result, actually you can bring any base to any other base because you can bring everything into e. But the problem is when you do that, you get a very complicated equation and it doesn't really help you to solve the problem. So that's why we don't go in that route. So what we're going to do, if you get a problem like that, the general technique, and it's already, you can see the exponential term is isolated. Since the exponential is isolated, so we done with the first step. So what we can do, we can take the natural log of both sides. That's the major step we can do to solve problem like that. So taking a natural log, or taking log of both sides, taking, we normally call ln, taking natural log of both sides. So if you take the natural log of both sides, what happened? This is ln 2 to the x equal ln 5. You can see the right hand side is done, it's ln 5. But what you can do here is you can use the power out formula. What's the power out formula? We discussed that in logarithmic properties of logarithmic equations. So it would be a good idea to look at them if you forget those results. So we talk about 5 properties in that. So this is one of the properties, the power out formula. If you have there's a power, you can take it out. So that means we can write this one as x ln 2 equal ln 5. So what is the result we use? So the result is if we have any log, any base, x to a power, you can take that power out, and then you can write this one as log ax. So that is what we normally call the power out formula. If there's a power, you can take it out. So that is the result we use here. So for, and then now you can see just divide both sides by ln 2. So that means you can finally write your solution as x equal ln 5 divided by ln 2. So that is the answer. So that's the exact answer, but if you need a approximation, what you can do is you can use a calculator and find those two values. For example, if you find ln 5, you're going to get 1.069, and if you find ln 2, you're going to get 0.693 up to 3 decimal places. And if you solve these two, you end up getting 2.322 if you round it to 3 decimal. So that is the approximate value for the solution of this one. Let's solve another problem. So for example, we can look at this one. So B, so we say solve, we can write this one as 5x minus 2 equal 3 to the, let's say 3x plus 1. So some functions, it doesn't matter what function we have. So only thing that we notice is they have different bases. Since they have different bases, we can take the natural log of both sides. So taking a natural log of both sides, taking natural log of both sides, we can write this one as ln 5 x minus 2 equal ln 3x plus 1. Now again, using the power out formula, we can take these things out. So what was the formula? So if we have ln x to the some power, you can take this power out. So we can write this one as p times ln x. So that means we can rewrite this one as x minus 2 times ln 5 equal 3x plus 1 times ln 3. So now what we can do, we can distribute. So we can distribute these two terms. So we can write this one as x ln 5 minus 2 ln 5. On the other side, we have 3x ln 3 plus ln 3. So we distribute. And then what we can do, we're gonna take the terms that have x to the left side and the other terms to the other side, numbers to the other side. So we're going to take all the x terms to one side. So that means we can write this one as x ln 5. If you bring the 3x terms, give negative 3x ln 3. And then we're going to be 2 ln 5 to the other side. It's going to be 2 ln 5 plus ln 3. Now you can see you can take x as a factor. So you're going to get ln 5 minus 3 ln 3 equal to ln 5 plus ln 3. Now what we can do, we can divide both sides by this term. So that means x equals 2 ln 5 plus ln 3 divided by ln 5 minus 3 ln 3. So that's the final answer. But you can, if you want, so that's perfectly fine. But if you want, you can do some few simplifications here. So for example, you can, this is not a must, but if you want, you can do that. So you can see that you can bring the 2 as a power. So that means you can rewrite this one as ln 5 squared. That means 25. And then this, you can leave it like that. And the bottom, again the same thing, this is ln 5, this is minus 3, you can bring as a power. That means this can be ln 3 to the power 3, that means 27. Now you can combine the top again. So this is a sum, that means the multiplication is going to be 75 because you multiply the two numbers, divided by this can be a division, it's going to be ln 5 over 27. So you can write it like that, and that's the end. So so you can like write as a simple form to bring it like that. But that's not a must, but you can do that if you want. Okay, so that's about that. So let's do another one with some decimal numbers and some EE as the base. So we're gonna do this one. So this is C. So let's say solve. How about this one? 0.3 equal 0.58 e to the 1 minus 2t. So t is a variable. So it's again go in the same direction. What we can do, we're gonna isolate the exponential term. So we're gonna follow the first step because it's not isolated. So we're gonna isolate the exponential term. How to isolate the exponential term? We divide both sides by 0.58. So we can rewrite this one as 0.3 divided by 0.58. So this is equal to e to the 1 minus 2t. Now you can see that the exponential is isolated, so we can take the natural log at this time. Also, if you want, you can also simplify this side. So if you divide 0.3 over 0.58, actually you end up getting 0.517 up to 3 decimal places. So it's an approximate value. So this is much simpler. So we divide that first. And now what we can do, take ln of both sides. So taking ln of both sides. If you take ln of both sides, you're going to see that ln 0.517 equal ln e to the 1 minus 2t. Uh, so we talked about this one earlier. If you have e, l and e, it likes they cancel out. So that means this is one of the property that we learned earlier. Uh, so uh, so that means this simply going to give you 1 minus 2t. So what was the result we learned? So we knew that ln e to the x equal x for any x. So that's the result we use. The other result is, so there's another result, is e to the ln x equal x. So the first one x can be anything, for the second one x has to be positive. Okay, so we use the first result here. Now you can see you can solve for t very easily. So that means you can see that the 2t equal 1 minus ln 0.517. Switching the terms, you're going to bring the 2t to this side, ln to the other side. Now you divide by 2. So that means t equal, if you divide by 2, 1 half 1 minus ln 0.517. So that's the answer for this problem. Also, you can see that you really don't need to use the ln every time. So like for example, let's say there's a problem that involve a lot of like a base 10 terms. So if there's a problem with the base 10 terms, maybe it might be worth to take like log 10. So so try to do these problems. I will give you another problem for try. So you can say, so theory, what we can do, I'm going to write it like that. So let's say you may also take other bases. So for example, log 10 or any other bases, any other log. So like it still give the same answer, but sometimes it might be easy to simplify depending on, for example, if you have a problem with e, we probably try to take natural log. If there's a problem with 10 powers of 10, we try to take log, like that. So for example, try to solve these problems. I'm going to give this as a D. So solve, let's say 10 to the x minus 3 equal 50 to 1 minus 2x. So you can see there are like a 10 involved here. So because 50 is, you can see it is 5 times 10. So in this case, we can take log or log 10. Okay, so see whether you can do that. So see whether you can get this. I'm going to give you the answer. So taking log 10 or log, that's how you know it. Taking log 10 of both sides, see whether you end up getting this as the answer. So x should be 4 divided by 3 plus 2 log 5. So see whether you get this as the answer for this problem. Log means log 10. Okay, so that's that. So let's try to go to the last types, the type 3. So type 3. So what's the type 3? You have more than 2 terms. More than 2 terms. So if there are more than 2 terms, the major method we can use is the substitution. So use a substitution. So let's look at maybe 2 problems and how to solve a like problem with more than 2 terms. So let's solve this one as the first one. So let's say solve 4 to the x minus 2 to the x minus 6 equals 0. And you can see that there are 3 terms in this one. So again, what we're gonna do is we're gonna notice something. We notice that you can write 4 as 2 squared. So that is the major argument we're gonna use here. So you can say since 4 equal to squared, we can write this one as 2 squared. You replace 4 by 2, and then x minus 2x minus 6 equal 0. So now this one we can write this one as 2 to the 2x minus 2x minus 6 equals 0. Now what we can do, we're going to switch the index, because the reason is, let's look at this algebra trick. So we have x to the y. This one you can write as a to the xy, and then you can switch the powers. You can write this one as yx. That means you can rewrite this one as a to the y to the x power. So that means you can always switch the powers. Xy or yx. We can use the exact same trick here. That means we can rewrite this one as 2 to the x squared. So we switch the powers. Minus 2 to the x minus 6 equal 0. Now what we can do, we're gonna let u equal 2 to the x. So if you take u equal 2 to the x, you can see that. So then what happened is simply u squared becomes simply 2 to the x squared. So again the same trick that we used earlier. So this is, you can write this one as 2 to the x. You switch the powers. So that means 4 to the x. So that means 4 to the x term is simply u squared. So you can see the 4 to the x term is simply going to be u squared. So we're going to see that here. So that means if you plug in here, it's going to be u, because 2 to the x is u. So it's u squared minus u minus 6 equals 0. Now we're going to factor. So this is very easy to factor. So the factors are u minus 3 and u plus 2. So this says that u equal 3 or u equal negative 2. Now what we're going to do, since we know that u equal 2 to the x, we're going to solve them separately. But there's a problem now, because we know that u equal 2 to the x. So 2 to the x is always positive. So u equal 2 to the x is an exponential function which is always positive. Because of that, this is not a possible solution. U equal negative 2 is not a possible solution because it is negative. So that means if we only have one solution, u equal 3. So we're going to continue with that. So u equal 3 is the solution. That means which is 2 to the x. Now we have a simple exponential equation. So 2x equal 3. So what we're going to do, we're going to take the natural log of both sides. So if you take ln of both sides as before, so taking ln of both sides, we have ln 2 to the x equal ln 3. The power comes out. So when the power comes out, you can rewrite this one as x equal ln 2. So we can write as a product. So it's going to be x ln 2 equal ln 3. This says that x equal ln 3 divided by ln 2. So that is the solution. So let's do one last problem, like a similar problem, but with e in the solution. So let's say solve 4 times e to the 2x plus 11 e to the x minus 3 equals 0. So what we can do as before, so we're going to let u equal ex. So then what happened, u squared become e to the x squared. So multiplying the power is going to be e to the 2x. So that means the 2x terms is simply u squared. So then we have 4u squared plus 11u, because ex is u, minus 3 equals 0. Now we're going to factor. So this one, like you can factor easily again. So what we can do with the number that we have is negative 12. So the two numbers that you're going to get is 12 and negative 1, because that's going to give you 11. So that means if using those two numbers, then you can factor this as 4u minus 1 and then u plus 3. So if you have trouble with factoring, you may watch the factoring video and I explain how to get these numbers quickly just by a simple division. Okay, so now what we can do, we can use those two factors separately. So you can see that, so we have for u minus 1 or for u minus 0 or um, u plus 3 equals 0. The same argument. This is that. So what happened now is we know that. So since u equal e to the x, which is positive, you can see that this cannot be, because when you add a plus 3 to positive number, there's no way it can be 0. That means this is not a solution because u is a positive number. When you add another positive number, there's no way you can get 0. That means that's extraneous solution. So we can remove it. So we only have one solution. So we have for u minus 1 equals 0. This says that u equal 1/4. So since u is e to the x, what we can do, we can set that equal. So we have ex, u equal ex, so 1/4. Now taking ln, so we're gonna taking ln of both sides. So taking ln of both sides, we're gonna get ln ex equal ln 1/4. ln 1/4 you can write as ln 1 minus ln 4, but we know that ln 1 is 0. That means this is simply going to be negative ln 4. And this side ln e get cancelled, so that means you're going to get x, this side simply x, or just use the power out formula, or ln e get cancelled. So x equal a negative ln 4. So that is the solution to the problem. There's only one solution. So this is about how to solve exponential functions, and we talked about earlier there are three types, and we solve all three types with different examples.